So I want to start talking about RC circuits. And if you've already seen them before, it might be a repetition, but I want to show it to you in detail. So what is an RC circuit? An RC circuit is the study of time varying currents. The R in the RC circuit stands for resistance, and C stands for capacitor. So we are going to look at the most fundamental of the RC circuits, which is going to be comprised of a resistor and a capacitor with an external source of EMF and a switch that can be toggled to points A and points B. The voltage drop across this is called Q over C, and the voltage across this is called V equals IR. So suppose for step one, we connect the switch to point A. We make that connection. What will happen? So let's say switch at position A will result in the capacitor starting to charge. Now, question: what current is set up in the loop circuit? How do we figure that out? Well, answer: use conservation of energy to figure this out. And how do I do that? Well, I'm going to follow a few steps. First of all, I'm going to assume that in time delta t, a charge equal to dq defined by I dt moves through any cross section of the circuit. This charge will be deposited on the positive plate of the capacitor. Number two, the work done by the EMF source, which is given by work equals EQ, must equal the internal energy defined as I squared R dt produced in the resistor R during time dt plus increase in du by the amount of energy Q squared over 2C stored in the capacitor. Where all of this now mathematically can be written as using conservation of energy E dq equals I squared R dt plus d q squared over 2c. Or may I also write this dq squared over 2c as 2q dq over 2c or q dq over c. So then this equation, may I rewrite this as E dq I squared R dt plus q dq over c. So far with me? May I divide throughout by dt? Will this become what is dq over dt? I. So may I write this as EI equals R squared R plus Q over CI? Or as it should be? Because what do we know about delta V across R and delta V across C? This is also called the loop rule equation from Intro 2, given as, all I've done is rearranged it. The total source of EMF minus the voltage drop across resistor minus voltage drop across the capacitor. So far with me? Okay, now may I rewrite this expression as E dq over dt R plus Q over C. Right, all I've done is I've moved this to here. Okay, or E minus Q over C equal dq over dt R. I'm going to do a little bit of rearranging. Or if I move this R from here to here, this implies, this implies, this implies. Okay, now watch this carefully. May I rewrite this as dt over RC equal 1 over EC minus Q dQ? Or in fact, can I write this as dQ divided by Q minus EC equal minus 1 over RC dt? May I now be allowed to integrate under boundary conditions that at t equals 0, the charge equals 0? That's when the switch is first closed. So what will my integration look like? Integration from 0 to Q, 1 over Q minus EC dQ minus 1 over RC integration dt from 0 to t. What's the value? Did everybody follow that step, right? The log, I did a couple of steps in the same. That makes sense? Okay.
Yes, all good.
Okay, perfect. That means I can also rewrite using the properties of log. Right? How do you get rid of the log? Use the exponent, right? Or may I rewrite this as Q minus EC equals minus T over RC? Taking the EC onto the other side and rearranging, what will I get? Q as a function of time will be 1 minus ET over RC. Where, if you note, RC is defined as capacitance time constant. And the way we define it is that this is the time at which the charge on the capacitor has increased to within a factor of 1 minus e to the power minus 1, or 63%. Of the maximum EC value. Now, but our basic question did not ask me about Q. My basic question asked me, what is the current setup in the loop? Now, I have a charging situation. How do I go from this charging situation to give me current? Current was defined as dq over dt. So can I do d over dt of this equation? Absolutely. So dq over dt will just be d over dt of EC minus 1 over minus T over RC, or EC 0 minus E minus T over RC minus 1 over RC. And this will be I on this side. Or I as a function of T will just be EC over RC e to the minus T over RC, where these two will get canceled. And these two will get canceled. And I will be left with I as a function of T will equal yay, current.